What's going on, guys? This video is a continuation of the first video of regular expressions made easy. So this is part 2, and now we're finally getting into some of the meat of regular expressions, character sets. So character sets are just special meta characters that represent sets of characters. Alright, so let's just get right into it. Earlier we had did a re.search, and we searched for ABCD. And when we run this, it finds the first instance of the literal characters A, B, C, D. Okay, so I run this and we get a match. Now, another way to search for characters is using the \W. Now, the \W, here we go. This \W, we just matches alphanumeric characters. So anything from A to Z, lowercase, A to Z, uppercase, 0 to 9 numbers, and one sort of special character, this underscore. So it's all digits, all characters, and this underscore. So here, this \W represents one character, \W represents second character, so we have 4 different characters. So we have 4 \Ws. So pretty much we're just looking for four characters that fit within this criteria. So in our case, all of these fit our criteria. So it should find the first 4, A, B, C, D. Let me run this. Okay. So yeah, so / represents any characters within this set. \W represents any characters within the set. So \W is a character set. It's a meta character that represents a character set. Let's look at another example. In this case, here we actually don't really need to use a regular expression because it doesn't really matter, but this is a raw string, but in this case I just left it because, I don't know, I just put it there for some reason. Alright, so \W, this is, we have 4 \W, so it's going to pull out 4 different characters. So A is part of this set, B is part of that set, this underscore is also part of this set that \W represents, and C is also. So it should pull out A, B, underscore, and C. So let's just run this. And it indeed matches the A, B, underscore, C. Okay. So, alright, so let's run another one. So in this case, this period is not part of the set that \W represents. We should get no hits. Because remember, we're looking for 3 consecutive \Ws. In this case, we only have 2. So let's just run this. Okay, and of course, we get no result. And of course, here, we're going to get a response, 833, and by using group, we can just pull out the string. So re.search, we search for 3 Ws, and we should pull out this as our string. So when we run this, we get 833. Okay. Alright, so the next character is a \uppercase W. So we were using a lowercase w, now we're going to switch to an uppercase W. And the uppercase W, if you guys know set theory, it's the complement of a \, lowercase w. So everything that's not included in \, lowercase w, \uppercase W will represent. So these two actually represent, so \W uppercase and \W lowercase represent everything. All the characters in the set. Okay. So pretty much nothing included in this portion. So everything that's not included in this portion is what \W is. So let's just run this again. Okay. So the earlier code, we couldn't pull out this, right? Because this is not included in the lowercase w. Now if we switch this regular expression with the uppercase W, so lowercase w, uppercase W, we should be able to pull out this expression. So let's just run this, and we get a match, A3 period. Okay, so another thing you want to be aware of is empty space is also a character. So in this case, we have 2 lowercase w's followed by uppercase W, and here we have an A3 followed by empty space. So this empty space is considered a character, and you'll see that when I pull this, when I run this code. When I run this code, we get the match A3 and an empty space. And empty space is the third character represented by this \uppercase W. Alright, there are tons of other character sets, but we'll go on with the other character sets later on. Now I want to go over something called quantifiers. Okay. All right, so quantifiers. These are also special characters, and they represent quantity. So how many times you want to do something. If you want to repeat something, if you want a certain pattern to be repeated, you use quantifiers. So in this case, so we're using /w twice, and then we're using uppercase W. Here we're using it 3 times. So we can use quantifiers to actually make this code more concise, get rid of some of the boilercode or the repetition. Alright, so the different types of quantifiers. So we have a plus. Plus represents 1 or more. A question mark represents 0 or more. An asterisk represents 0 or more. And then we have these curly brackets and N and M. And those represent N to M repetitions. So this is the least amount of repetitions, and this is the most amount of repetitions you're searching for. So it's pretty much like a range from N to M. And you can also get rid of the lower bound or the upper bound by just leaving it blank, leaving the N or M blank. So in this case, when we leave this blank, it's saying any number up to 3. And here, with 3, N representing 3, it means from 3 to any number. So 3 to infinity in a sense, as many as you want. But we have to have at least 3 repetitions. Alright, so let's just look more into quantifiers. Okay, so in this case, we have 2 W's. So we're going to pull out 2 different characters. Okay, now here, we're actually using the plus quantifier. So if you guys remember, plus means 1 or more. So in this case, it's going to pull out 1 or more of this /W. This plus is called a greedy quantifier. So it's going to take advantage of the more. So it's going to pull in as many. So instead of pulling in, say, the least amount, it's going to pull out the most amount. So in this case, the least amount will be 2, 1 actually, because it's asking for 1 or more. So this quantifier is asking for 1 or more of this /W. Always remember the quantifier comes after the character. So in this case, this quantifier is representing the meta character before it. And 1 or more, since it's a greedy quantifier, it's going to satisfy that more. So let's see. So /W, if you remember the character set, it's all the digits and numbers. It represents all the digits and numbers. So in our case, this is our string. So it's going to represent all of this, but it doesn't represent this empty space. So 1 or more means it's going to keep going until it hits something that it can't include within this regular expression. In this case, we don't have anything to represent this empty space, but all of this fits the criteria of 1 or more /W. So being a greedy quantifier, this plus, it's going to take on all of this, and then once it hits this empty space, we have no character representing the empty space, it's going to end. So it's going to pull out all of these characters. So 1 or more means as many characters that fit this /W criteria. So we run this, and we get all of this. Okay. Yeah, I could just leave this, I guess. Okay. So array.search. Now we're going to use change up the code a little bit. We're going to put the complement W in the middle. So now this should take care of the empty space. So we have as many characters with the little space, as many alphanumeric characters. So it's going to take up all this, and then it's going to hit a roadblock here. So it's just going to pull out all this, and then this character is going to search for as many lowercase w characters. So it's going to search for all that, and it's only 1 character in this case. So it's going to pull that. So this ends. So we have all this. And then this uppercase character is going to continue from there and look for as many uppercase W characters, which in this case it's only the empty string. Then that ends. And then we have this, which is going to look through the rest and pull out as many lowercase w characters. In our case, it's all of these characters, and the string comes to an end. So essentially, we're going to pull out all of this. So let's just run this. Okay, so we've pulled out everything. Now, it doesn't matter how many empty spaces there are. If we put a plus, see this plus here? This plus means 1 or more. So in our case, there's more, 1 or more, 1 or more, 1 or more. All of this criteria fits this W plus, so this should run as well. Okay, let's just, this should pull out the whole thing as well. So let's just run this, same code, and we indeed pulled out the entire string. Okay, Now let's just look at the question mark. So the question mark means 0 or more. So it's optional. It's sort of like it could be there, it doesn't have to be there. So in our case, this W plus is going to pull out everything, right? And the string comes to an end. But we also have to fit this other criteria. So what happens, I'm assuming, so this W plus will, since it's greedy, it'll take the whole thing out. But then, since we have to also fit the rest of the criteria, it might just go back a couple and allow these W plus to fit the criteria as well. I'm not sure exactly what's going on in the back, but this works because this W question mark is essentially saying there can be a space, but there doesn't have to be a space. Remember, this is either 0 or 1. So we can have either 0 or 1 of this backslash uppercase W. So this code will also pull out this entire string. Okay. Now, the same code is flexible. So if there's, say, one space, if there's a space here, then it'll be able to pull out this entire portion. Because remember, this says either 0 or 1 space. So in this case, there were 0 spaces, so we didn't need to use this backslash uppercase W. But in this case, we need to utilize this backslash uppercase W to take care of this. So this string will pull out this string. So this regular expression will pull out this string as well, and this string as well. So let's just run this. Okay. So now let's just test. Let's just go back and let's just pull out this code with our string. Let's see. Okay. So as you can see, this code should not work with this. Let me just run this. Okay. Let me just fix that. Okay, this looks good. Okay, none type has no group. Okay, so this doesn't run. So as you can see, this code works here with these two, but if we switch the quantifier to 1 or more, so remember, it's forcing the regular expression is looking for a string or a portion of a string that has at least 1 or more of these. Now these were just asking for 0 or more, so it's optional. In this case, you have to have at least 1. In this string, there is no backslash uppercase W, so this will return a none. There's no object. So an empty result set. Okay. Alright, so the next thing I want to go into is pulling out specific amounts. So here, this quantifier is 0 or 1. This is 1 or more. Now, if we want to pull out specific amounts, we can actually do so with curly brackets. All right. So here we're asking for only 3 characters. So backslash W, we want this to be repeated 3 times. So we want backslash W, backslash W, backslash W. We want 3 backslash W's. So this quantifier represents 3. It's an exact number. We run this, and we get AAA, which represents 3 characters, 3 backslash W characters. Now remember, before I had talked about ranges, so you can have, you can pull out from 1 to 4. You get an option. So this gives you more flexibility. It gives you a range from 1 to 4. So it's going to look for 1 to 4, and it's greedy, so it's going to pull out 4. If it can pull out 4, it'll pull out 4. So it's always looking for how many it can pull out. The max it can pull out. So in this case, it can pull out 4, so it pulled out all 4. So this quantifier is just the 1 represents the minimum, and the 1 represents the maximum. So 1, 2, 4. Okay, so just another example. These quantifiers can be used multiple times. So, and they come after the character or the meta character. So in this case, we want 1 to 10 of the lowercase w, 0 to 4 of the uppercase w, and then 1 plus of the lowercase w. So 1 to 10. So you have the option of 1 to 10, then 0 to 4, and this should pull out this whole string. So let's just run this, and it indeed pulls out the entire string. So let's just run this as well. So this is min max. Remember I told you this 1 represents at least 1, and this if you leave the upper bound range empty, that means as many. So it's looking for 1 plus, so at least 1 and as many w's as you can get. And here, in this case, the uppercase w represents 0, so it's pretty much essentially saying 0 to infinity. So either you can have 0 or you can have infinity. And then you're looking for the lowercase w plus, this plus represents one or more. So let's just go through this again. The one represents at least one, and you can, since this is empty, it means as many as you can fulfill. So this is greedy, so it's going to fill as many as you can. And this is also greedy. You want at least 0, and you can fulfill as many as you want. So this is pretty much just optional. You can have, this doesn't have to be included, or you can have as many as you want included. All right, so let's just run this, and we plot all this. Okay, so I'll end this video here. The next video, I want to go over some more more character sets. So I'm going to leave this here because I don't want to overburden you guys with the information. And yeah, so I'll leave you guys there.